Okay, this is section 1.6. This is part 2. In this second part, we're going to be solving equations with rational exponents. We're going to be solving equations quadratic in form. And then we have this little bonus. We were given this little equation with some fractions, and you're supposed to solve for capital R. In the previous video, we answered we solved some other types of equations. We solved rational equations. We did a work rate problem, and we did some equations with radicals. And so now we're answering questions 7 through 11. If you haven't had a chance, what you should do at this point is write down these equations. Try to do them on your own. See if we come up with the same answers. And if we don't, then just watch the rest of the video to see the steps in between. So right now we're going to be doing 7 through 11 in this video. Okay, so let's get on with it. Let me scroll down here to give ourselves some room. Okay, so let's begin solving equations with rational exponents. So rational exponents. So the exponents are going to be fractions. And I kind of want to give you a bit of a warning here, because there are two, within rational exponents, you have rational exponents that have an even denominator, and you have rational exponents that have an odd denominator. And the way you treat these rational exponents is a little bit different. So we know that there's a connection between radicals, nth roots, and exponents. So the nth root of a is the same thing as a to the 1 over n. So this is a fact about exponents that allows us to go between radicals and exponents. And so then, if you think about it here, if you have this is a rational exponent right here. It's a fraction exponent. My numerator is 1. My denominator is n. So think about the denominator as if you have a rational exponent, if you have an exponent that's a fraction, think about the denominator as talking about a root. Okay, so since we know this fact, that the nth root of a is equal to a to the 1 over n, then there are two ways of solving this equation. X to the n equals a. So think about how you would solve this equation. X raised to the n equals a. One way would be to take the nth root of both sides. And so then x is equal to the nth root of a. Another way to do this is to raise both sides of this equation to the 1 over n, the reciprocal of this exponent. And that would say that x is equal to a to the 1 over n. It's the same thing. So taking an nth root and raising to the power of 1 over n is the same thing. And so here's a warning. Whenever you're solving an even polynomial equation, So whenever you're solving an even polynomial equation, you need to take an even root, which results in multiple solutions. So for instance, think about this equation right here. X squared equals a. Let me solve it. One way to solve it would just be to take the square root. But if I take the square root, there's this business of plus and minus, plus minus. So x would be plus minus square root of a. Well, if I was to solve it by using exponents, that would say x is equal to plus minus a raised to the 1/2. If I had this other equation, x to the 4th equals a. Well, in order to solve it, I would take a 4th root. X equals plus or minus 4th root of a, or x is equal to plus or minus a raised to the 1/4. And so think for a second here. If you are dealing with an even polynomial, if your exponent is even, you're going to have to take an even root. And even roots always have this plus or minus associated with them. Yeah. So if your exponent is 1 over something even, then you're going to have plus or minus. So you're going to have to include plus or minus. So keep that in mind. So now, if you're solving an odd polynomial equation, you need to take an odd root, and this results in just a single solution. So for example, I have the equation x cubed equals a. In order to solve that equation, it's just the cubic root of a, or a to the 1/3. Notice here that there's no plus or minus. Over here with the even ones, there's the plus or minus. Here with the odd roots, there's no plus or minus. If I am trying to solve this equation, x to the 5th equals a, well, that's just the 5th root of a, or a raised to the 5th, to the 1/5. And so then if you have an exponent that's 1 over odd, then no, there's no plus or minus to be involved. So keep that in mind. We're gonna use that in one of the examples that we work out. Okay, so let's begin with our first example. We have some rational exponents here. So 5x to the 2nd minus 12x plus 6, all of that raised to the 1/3. Minus x to the 1/3 equals 0. Okay. And well, we can either just work with rational exponents if we wanted to, but in this case we can think of this rational exponent as if it's just a radical, because we know that a to the 1/3 is equal to the cubic root of a. So I could just change the problem to a radical problem, which we've worked already on before in the previous video. So that's what I'm gonna do. I changed my rational exponent to just a radical. So now I have a radical equation. And we said that in order to start solving these radical equations, it definitely helps to isolate a radical. So I'm going to isolate a radical. So I have a radical on the left-hand side, I have a single radical on the right-hand side. And now I'm dealing with cubic roots. So in order to get rid of cubic roots, I'm going to cube both sides. And if I do that, then the cubic roots are gone, and I end up with a quadratic equation. So this quadratic equation, what I'm going to do is set it equal to 0 and try to factor. So I'm going to subtract an x. That's how I end up with this negative 13x. Now it's set equal to 0. And now I got to think about this quadratic equation right here, and I need to think about whether or not it can be factored. If it couldn't be factored, you would have to use the quadratic formula. In this case though, it can be factored. It factors as 5x minus 3 times x minus 2. And well, then that leads to the solutions x equals 3/5 and x equals 2. And now you still have to check your answers. And in this case, turns out that both of the solutions, 3/5 and 2, give us valid answers. I'll let you do the checking on your own. But I mean, you should just get in the habit of checking your solutions, no matter what type of equation you're dealing with, just to make sure that your work is correct. Okay. 1 second here. My computer is not allowing me to see my notes here. Let's see. All right, so I'm checking some answers for this first exercise here. Check your answers. Turns out that, yeah, both of them are answers. So the solution set, I guess what we should say here is that the solution set in this particular case is 3/5, 2. Okay, next example. In this example, so I was given this equation, x plus 7 raised to the 2/5 equals 4. I am going to raise both sides of this equation to the reciprocal of this exponent. So right now it's 2/5. So I'm going to raise both sides to the 5/2. So I'm raising each side to the power 5/2. And notice that the denominator, the denominator of my rational exponent is even. So I'm going to need the plus or minus, because that means that I'm dealing with an even root. The 2 in the denominator is what tells me that I'm dealing with an even root. So if I raise everything to a fraction and the denominator of that fraction exponent is even, I need to introduce plus or minus. So this becomes x plus 7 equals plus or minus. So that's why this plus or minus is here, 4 to the 5/2. And then I'm going to have to evaluate what is 4 to the 5/2. What is 4 to the 5/2? Well, you can think about it as the square root of 4 raised to the 5th, or the square root of 4 to the 5th. If you think about it as the square root of 4 raised to the 5th, that's just 32. So then I have that x plus 7 is equal to plus or minus 32. And then I solve each one of these equations. I subtract the 7 from both sides in both equations, and I end up with a solution set 25, negative 39. I checked that my answers actually were valid, and you should as well. Okay, so hopefully we agree on these first two equations. Now let's talk about equations quadratic in form. So let's just jump into this exercise number 9. X plus 1 raised to the 2/3 minus x plus 1 raised to the 1/3 minus 2 equals 0. What I'm going to make here, what I'm going to do here is, I realize that, there's this x plus 1, there's this x plus 1. I'm going to replace it with something a little bit simpler so that this becomes actually just a quadratic equation. And so then I realize that if I let u be equal to x plus 1 raised to the 1/3, then my original equation becomes u squared minus u minus 2. And now I'm in another variable. I'm in the variable u. And I'm going to try to solve this equation for u now. So in order to solve for u, I'm going to factor it. So this factors as u minus 2 times u plus 1. Okay, so that gives me solutions u equals 2 and u equals negative 1. But I did start with the variable x. So I'm going to replace now u back with x plus 1 to the 1/3. So u equals 2 becomes x plus 1 to the 1/3 equals 2. U equals negative 1. That becomes x plus 1 to the 1/3 equals negative 1. And now I gotta solve these equations for x. To get rid of the 1/3 exponent, I gotta cube. I gotta raise everything to the reciprocal of that exponent. So the reciprocal of 1/3 is to the 3rd. So that's cubing. So I gotta raise everything to the power of 3 on both sides. On both equations. Right now I have two equations to solve. So I raise everything to the power of 3 on this left equation, everything to the power of 3 on this right equation, and I solve for x. On the left equation I have x plus 1 equals 8, because 2 to the 3rd is 8, and on the right hand side I have x plus 1 equals negative 1, because negative 1 times itself 3 times is negative 1. And then I just solve for x. So I have x equals 7 and x equals negative 2. And again, you should check your answers. You should plug your answers back into the original equation and see if it's satisfied. And turns out it is. So my solution set is 7, negative 2. All right, let's try another one of these equations quadratic in form. In a sense, it's just a quadratic equation in disguise here. So let's think about this one. So here I have 10x to the negative 2 plus 33x to the negative 1 minus 7 equals 0. I am going to make the substitution u equals x to the negative 1. And so then this becomes 10u squared plus 33u minus 7 equals 0. This is just a quadratic equation now. And so then having good factoring skills helps out here, because now you have to think, can I factor this? Is it even factorable? Because if it's not, then the quadratic formula is the tool to use. But turns out that this is factorable. It factors as 5u minus 1 times 2u plus 7. So it factors, and that gives rise to two solutions. U equals 1/5 and u equals negative 7/2. And now I gotta replace my u with x to the negative 1. So I have x to the negative 1 equals 1/5 and x to the negative 1 equals negative 7/2. Now x to the negative 1 just means 1 over x to the positive 1. So what we can say is that x to the negative 1 is just the reciprocal of x. So if I'm trying to solve for x here, then I gotta think, okay, well, what's the reciprocal of 1/5? Well, that would be 5 over 1. What's the reciprocal of negative 7/2? Well, that would be negative 2/7. Yeah? And then I still gotta check my answers. I gotta make sure that my answers work out. I already checked them, but I encourage you to check them yourself. It turns out that they are valid answers. So my solution set is 5, negative 2/7. Okay. The last thing, this little bonus question. You were given this equation with 3 fractions. You're supposed to solve for r. Okay. I'm going to try to solve for r. I think I kind of want to cross multiply here. But in order for me to cross multiply, it would be nice if on the right hand side of this equation there was only one fraction. Right now there's 2. It's a sum of fractions. Well, to make it into a single fraction, I should just do the addition. I should just add these 2 fractions. So I need to find a common denominator for them and then add them. So that's what I'm going to do. I'm going to add the fractions on the right hand side of the equation. So I think a good common denominator for these 2 fractions is r1 times r2. So that means that this left little equation right here, I'm going to multiply it by r2 and r2 in the denominator and in the numerator. This little equation over here on the right, I'm going to multiply by r1 and r1 in the denominator and numerator. That's what I've done right here. And now they have a common denominator, so I should be able to add them. And this is what the sum looks like. Now it's a single fraction. And now I'm going to cross multiply. So I'm going to multiply this denominator times 1, and r, capital R, I'm going to multiply it times this sum. So I cross multiplied. And then the last thing is to solve for r. So I'm going to divide both sides by that sum. And that is it. I have solved for r. Okay, so that's it for this section. Hopefully this types of videos, or sorry, these equations were not too difficult to solve. And I'll see you in the next video. Thank you.